Although the beneficial effects of caloric restriction on lifespan and health have been clearly demonstrated, it is difficult to implement such restrictions in our lives. In the classic Minnesota starvation study, many of the volunteers suffered a preoccupation with food, constant hunger, binge eating, lots of emotional, psychological issues. Even researchers who study caloric restriction rarely practice it. There's got to be a better way to suppress the engine of aging enzyme, TOR. That's why researchers were so excited about rapamycin, a drug that inhibits TOR, thinking it could be caloric restriction in a pill. But like any drug, it's got side effects too. There's got to be a better way. The breakthrough came when scientists discovered that the benefits of dietary restriction may be coming not from the restriction of calories, but from the restriction of protein intake. If we look at the first comprehensive comparative meta-analysis of dietary restriction, the proportion of protein intake was more important for life extension via dietary restriction than the degree of caloric restriction. In fact, just reducing protein without any changes in calorie level have been shown to have similar effects as caloric restriction. That's good news, because protein restriction is much less difficult to maintain than dietary restriction, and may be more powerful than dietary restriction because it suppresses both TOR and IGF-1, the two pathways thought responsible for the drastic longevity and health benefits of caloric restriction. And some proteins are worse than others. One amino acid in particular, leucine, appears to exert the greatest effect on TOR. In fact, just cutting down on leucine may be nearly as effective as cutting down on all protein. So where is leucine found? Predominantly animal foods, eggs, dairy, and meat, including chicken and fish, whereas plant foods have much less, fruits, vegetables, grains, and beans. In general, lower leucine levels are only reached by restriction of animal proteins. To reach the leucine intake provided by dairy or meat, we'd have to eat like 9 pounds of cabbage. That's like 4 big heads of lettuce, or 100 apples. These calculations exemplify the extreme differences in leucine amounts provided by a more standard diet in comparison to a plant-based diet. The functional role of leucine in regulating TOR activity may help explain the extraordinary results reported in the Cornell-Oxford China study, since quasi-vegan diets of modest protein content tend to be relatively low in leucine. This may also help explain the longevity of long-lived populations like the Okinawa Japanese, who have about half our mortality rate. The traditional Okinawa diet was only about 10% protein, and practically no cholesterol because they ate almost all plants. Only 1% of their diet was fish. Meat, eggs, and dairy less than 1%, the equivalent of 1 serving of meat a month, 1 egg every 2 months. Their longevity surpassed only by vegetarian Adventists in California, giving them perhaps the highest life expectancy of any formally described population in history. And now we may be a little closer to answering the mystery as to why populations eating plant-based diets live the longest.